and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Chelsea Jewell.
Thanks, William, and thanks everybody for coming today for our case study series. So we're talking about seated rust in this one, and it's going to be a combined look at the origin of corrosion and when protection is needed for ferrous materials. So this opportunity started, we had an automotive company that reached out and they were looking to find a process to remove an existing corrosion preventative on their incoming parts. They also wanted to do some machining and then apply a new corrosion preventative for 90 days of protection on these. They were a machine cast ferrous type part. So looking at the challenge, once we had samples in our lab, a visual inspection of the surface of the parts showed severe pitting on the surface. We dug a little bit deeper with SEM inspection and saw that there were deep divots in the surface of the parts. We also found some oxidation sites. We found silica and a little bit of carbon, which could potentially be the existing CP, but there are definitely a number of materials on the surface of this part incoming. From there, trying to dig a little deeper into what this pitting could cause as far as issues go. We put this part into our humidity chamber, and within hours, we saw severe oxidation on the surface of the part. And you can see in this image, these red oxides formed very close to the areas that we saw those pits with our visual inspection and SEM. So to start this process, after we saw the initial results from their CP, we started a more in-depth look of what was going on with this. Because of the nature of corrosion, we're not going to be able to take the existing CP off this part, put a new one on there, and continue to protect. That corrosion's there. It already exists on the surface. So there's two avenues that we have to take at this point. The first being to remove the oxidation in an aqueous process or an acid process. The second would be, figuring out where this came from, how it started, and see if we can fix it before it even began. Most of our testing revolved around our humidity chamber. This chamber was set to simulate 90% relative humidity and 90 degrees Fahrenheit. This is typical for all of our automotive evaluations. The parts remain in the chamber for 10 days, and this correlates to 90 days of real-world time in those conditions. What we started originally to develop for this process is using our combination product, which is Metalnox M6324CP. This was used to remove the existing CP so we could get a deeper look at what was going on the surface. Originally, what we found with this type of corrosion is the best practice is not to allow the corrosion to develop. From that point, when you're looking at these parts visually, everything may look okay, but when you dig deeper, there are sites that are just waiting for the right conditions for that corrosion to start to bloom. Those combination products are very key in this type of cleaning because not only are they able to clean more difficult soils, but all along that process, there is a corrosion preventative on the surface that it's able to protect the part. If it's not possible to keep the corrosion from forming on the surface, we can implement a mild acid cleaner such as Metalnox M6093. But what you do along that process, you've taken an acid and you've scrubbed that surface essentially. So now that there is bare metal, it has to be protected. This can become a problem if operators are not paying attention or you're not able to move parts through the wash process as fast as possible. Implement those corrosion preventatives along the way. Our KYZEN CP90D is also a good option for longer term protection, and this is kind of the branches that we looked at for a solution for this customer. Overall, ideally, the best way to prevent corrosion from occurring is to never let it happen. Going through each stage of that manufacturing process and seeing where those developed, where those, sorry, where that corrosion develops is very key in understanding the best cleaning method for it. It's tough to guarantee that all of those nucleation sites have been removed once rust has formed. Um, you tend to look at parts visually and everything looks okay, but that deeper inspection, even with using an acid to clean that rust off, it's hard to guarantee that everything has been removed. What we also recommend is regularly inspecting the tooling. As tooling is used, especially on metal surfaces, depending on what coolants and lubricants you're using, you can create wear and metal particulate can come off of that tooling surface and get embedded, and you're transferring, potentially one contamination to the surface of the part. And with corrosion, it can start from that and bloom and grow from there. We always recommend handling any type of ferrous material with gloves to prevent contamination. You can see rust that form in the patterns of fingerprints that will happen sometimes. Also, allowing parts to come to room temperature before packaging. Most of these parts will, going through any type of drying process, they'll hold a lot of heat in order to flash the water off of them. Putting a hot part in a plastic bag and sealing it, you're basically creating your own humidity chamber at that point because that moisture that was in the air has nowhere to go. Making sure they come to room temperature before packaging, or VCI bags, VCI paper, those are always best practices when it comes to the parts moving to the next stage. So what we looked at as far as a solution for this customer, our results in the humidity chamber before, you can see a visual inspection and microscopic inspection of the surface of this part. This was within hours of the part going into the humidity chamber that we saw a lot of rust form. Typically, it lined up with a lot of where that pitting was on the surface. What we found is some of the parts, the corrosion was occurring during transfer from one side to the other. Others, it was during the machining process. What we moved them towards is cleaning with our 6324 CP along those stages of the process. And it actually prevented the rust from ever forming. So we didn't see that severe corrosion. So initially, our results, we were seeing a heavy level of corrosion within a few hours in the chamber, whereas these parts were in the chamber for 10 days, which equates to 90 days of real world time in those conditions. This saved a significant amount of effort, I feel like, on trying to prevent rust along the way rather than removing that corrosion. So looking at kind of how we wrapped everything up, this customer had two different suppliers. With one, they decided an internal wash within that supplier was a better option and it protected the parts along the way. The second supplier, they weren't able to change out their cleaning process. So what we used was a 6324 CP in their wash to be able to clean, and then used our KYZEN CP90D for longer term protection. So both of these steps prevented the seed rust from occurring and simplified their life, I would say, drastically. They weren't chasing this corrosion issue every time it got a little too humid, or parts set out for longer than they were supposed to. They also added an increased level of inspection for the tooling, so they weren't seeing any type of transfer of metal particles from that process as well. So a couple questions about seeded rust that we tend to get often. I would say the first question I always get is, was the acid treatment the best option to remove the corrosion? Overall, the acid treatment will work, but it creates a couple more complicated things along the way. You have to be able, you've removed all of the protection that metal has at that point. A new layer of protection has to be put on. But in that time where, if you have an aqueous washer and you're sitting in the wash zone for any period of time, or, as you come out of an immersion wash and it's sitting over the tank, those times are when flash rusting can really occur. because it's sitting in that humid environment. There's no protection on the part. So understanding how the part moves through your plant, how the operators are moving them is really key to keep everything protected along the way. So while it's definitely an option, it just takes some practice to make sure that it doesn't make things more complicated. As far as storage for parts, I recommend once parts have come to room temperature, VCI bags. They're great for keeping corrosion, keeping humidity out, and minimizing any type of corrosion you'll see while the parts are stored. VCI paper is definitely an option. Any type of desiccant that's going to dry out that environment and keep those parts from rusting is key. And then, preventing flash rusting in the cleaning process. What I like to look at for this is, where are your pain points along the process? You know, try to create worst case scenarios. Say if the washer gets stopped and the part is sitting at a certain point, on the belt or, even over the tank. How long do you have with that flash rusting before that flash rusting occurs? You try to diagnose possible issues and see if there's simple ways of fixing those problems. If you're worried about getting an oil off and keeping the parts protected, those combination products, no matter what type of metal you're really cleaning, is are great because along the way it's always protected. Understanding how long you need that protection to last is key too. You know, Flash rusting, it once it starts, it's very hard to fix it. We go back to the acid treatment and you're like, well, I'll just clean it that way. But that can lead to a couple other problems as well. So prevention, I feel like it is the key, and the best way to prevent the flash rusting that I've seen is understanding your cleaning process and where those pain points are. So with that, I will turn it back over to William. Thank you so much.
Thank you, Chelsea. Thank you all for watching this Tech session. If you'd like to discuss this topic further or have any questions not answered in this session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description below. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.